All right, so we're back to start 3.4. The first thing we're going to do is go over a little bit of the PowerPoint, and I'm going to do some examples. Let me share my screen with you. So here we are. Let's go to our PowerPoint. So first example, or the first derivative test was finding critical points, and the critical points were either relative maxes, relative mins, or neither. And in between those points, we could have increasing or decreasing functions based off of what the derivative was, positive or negative. The second derivative gives us concavity. Concavity, it can be concave up or concave down. Concave up is your right side up parabola, right? It says it holds water. Concave down is the upside down U. It would spill water. Right, so if you want to tell whether a function is concave up or concave down, you're going to have to use the second derivative. Now, this comes into play because if you have a maximum value, it has to be on a part of the curve that is concave down in order to be a maximum. And in order to be a minimum, it would have to be on a part of the curve that is concave up. So the second derivative test is going to just verify what our first derivative test told us. Right, if we have a max, it will be on a concave down. If we have a min, it will be on a concave up. So here, once again, if you have a function that is twice differentiable, it is concave up on any interval where the second derivative is greater than 0. So if the second derivative is positive, it is going to be concave up. If it is concave down, it will be less than 0. So let's go ahead and get into this example. Let me go to my document camera, and I will share that with you. All right, so here we are. We have this function x to the third minus 12x minus 5. Right, first thing we need to do is find the first derivative, which I'm not going to spend a whole lot of time because on a function like this, I think most of you are pretty comfortable. Right, it's going to be 3x squared minus 12. If I wanted to find critical values, the extrema, I would use the first derivative test from here. However, for this one, I'm going to find the second derivative. Second derivative, the derivative of the first derivative, would just be 6x. And in order to do the second derivative test, much like the first derivative test, I'm going to set that second derivative equal to 0. Right, find out when the second derivative is 0, which in this case, of course, would just be 0. So I'm going to make my second derivative line, and these are called points of inflection, right? This point that you find is a point of inflection on the first derivative. It was called a critical value. On the second derivative, it's called a point of inflection. So I'm going to put my point of inflection on here at 0, and then I'm going to test the second derivative at two different values, a value to the left and a value to the right. So if I put a -1 in, that's 6 times -1, which is negative. If I put a +1 in, that's 6 times 1, which is positive. Once again, I don't really care about the values. I care about the signs of the values because that's going to tell me whether it's concave up or concave down. If it's a negative, that's going to be concave down. If it's a positive, that's going to be concave up. So you would write it as an interval. Right, this function is concave down from -infinity to 0, and it is concave up from 0 to infinity. Right, so that is the second derivative test. Now, ideally, once we start on the whole process, what we're going to do is we're going to go do the first derivative test as well, find the max or min, and make sure that this second derivative verifies what that first derivative has to say. But if it just asks for concave up or concave down, this is what we'll be doing. So let's take a step back and let's try the first derivative test. So if I set the first derivative equal to 0, right, that's going to be 3x squared equal to 12. X squared is going to be 4. So x would be plus or minus 2. So on my first derivative line, I would have -2 and 2, right? If I put a -3, so let's do f prime of -3. Well, that's -3 squared, which is 9. 9 times 3 is 27. 27 minus 12 is a positive number. If I put 0 in, 0 minus 12 is a negative number. Positive 3 would act the same as -3 because of the square. That's positive as well. So if it goes increasing to decreasing, that's a max. Decreasing to increasing, decreasing to increasing, that would be a minimum. So at -2, -2 is over here on my second derivative line. It's concave down, which has a max on it. That makes sense, right? Concave down looks like this. It makes sense that there would be a maximum on that value, on that interval. Concave up, over here at 2, would be over here greater than 0. There's a minimum. If it's concave up, it makes sense that there's a minimum there. So second derivative, first derivative, those tests work together. Both of them, you're finding the derivative setting equal to 0 or when it's undefined for some of your harder functions. First derivative, these points are called critical values. Second derivative, like I pointed out before, they are called points of inflection, right? You make sure when you do the second derivative test, when you test values on your derivative line, you plug them into the second derivative. When you test values on your first derivative line, you put them into your first derivative, right? You're not putting them back into the original for these. You're putting them into either the first or second derivative, depending on which test you're doing. So that is that. We'll do some basic examples in class or in our classwork today, and then I'll come back with another video with maybe some trig functions or harder problems for tomorrow. Good luck. If you have any questions, feel free to ask. Make sure you like the video and subscribe. See you tomorrow.